Thank you very much. It's my first time at DjangoCon, so thank you for the applause before speaking. It's very nice. So yeah, as I say, it's my first time, and I'm all by myself, so do come say hi if I look lonely. And I'm going to confess, the main reason I'm doing this talk is that I just want to talk to you about research software engineering for a few minutes, and then I'll tack some Django stuff on at the end. Out of interest, has anyone come across the term research software engineering before? Yeah, we got a smattering of hands. I thought there was some. There's probably some of you out there, I imagine. We are everywhere. It's quite a simple idea, really. It's research plus software engineering. It's not a very innovative name, perhaps, but it kind of represents the idea that research involves developing an awful lot of software. We should probably do that well, right? And it's a very simple name, but I think you can't really overemphasize the level to which the name has been really, really key for us. So there've always been this sort of, well, not always, but since sort of computing and programming became something that happened in research, there's always been this class of person in the academic system who had this skill set around developing software, but they were just never able to progress within the academic system because that's not how the rewards are structured, right? You can't get very far by spending your time being good at programming. You have to spend your time writing papers and getting grants and doing all that stuff. About 11 years ago, I think someone came along and like in a workshop in London, I think basically a bunch of people in this situation came together and they invented this term, research software engineering. And that has basically been the catalyst for this kind of grassroots movement that's kind of sprung up across academia with this mission around improving the quality, sustainability, and the impact of software that is developed as a part of research. It's going pretty well. So I can say, 11 years ago in London, the idea was first coined. It's now really is a large number of organizations across the world in various places. And what has sprung up around this as well is what we call RSE groups, which are basically teams embedded within universities that have a focus on software engineering within the institution and sort of working with partners in the research space to help them develop software. There are some groups all over the world, and the UK has been a real place where this idea has really taken hold. So, these are not necessary beliefs to be a research software engineer, and there's certainly not universal beliefs amongst research software engineers, but I would certainly argue these are pretty typical and things that you will find people often believe. And so we see ourselves as quite aligned with the concepts on open source, and we're interested very much in that mindset around how we can collaborate rather than necessarily compete. And that basically software is fundamental to research, and good software engineering is fundamental to good research. Very briefly, just going to whip through a couple of things about how we do RSE at Imperial. So, different countries and institutions have all kind of come up with their own kind of model for how to actually do it. We're a growing team. We're currently less than 10, but we're doing a good job of tying on lots of new roles, and we hope to breach that soon. Some of the larger teams in the UK are 30, 40 people. We basically work as a consultancy service inside the college, so academic groups stump up cash, and we work with them. And we have this sort of funded body of work is kind of our main thing, but we also have this very general remit around improving the quality of software that is developed at the college. And we kind of get this mix of people coming in, some people coming in from kind of like a programming, software engineering background, but also a lot of people coming in from the academic research kind of background, much like myself. What we kind of end up working on is a really, really broad range of stuff, probably too broad a range of stuff, but it kind of means we're a team of generalists doing everything from graphical user interface development to supercomputing. So what does Django make sense for us? And Django is our kind of go-to framework for anything we need to stick up on the web. Because we're a team of generalists, Python is great. You can do basically anything in Python. Maybe it's not the best language for everything, but you can do everything with it. So that means it's kind of our common language and something that a vast majority of our work ends up being done in, although we do still have a bit of Fortran floating around. We are usually time resource constrained, but we do want to do things right. So perfectionist with deadlines sounds pretty bang on with what we want to do. And it's really important that we have something standard across the team. We have a lot of people who've never done web development before. Introducing them to multiple web frameworks would be tricky versus just one. And the built-in guardrails to Django make it really great. The kind of standard ways of doing things, the emphasis on security, all good. And of course, it's open source, which is awesome. And it's kind of easy to get people started on as well, in that you have that great tutorials and easy things to get going. I'm just going to leave a few things there as I am done.
Fantastic. On time.
Hello. Today I'll be talking about deconstructing salsa moves with finite state machine perspective. What is salsa? It's a lively, rhythmic, and social partner dance. By social dance, I mean there is no choreography needed. You can improvise along the way. There are two roles, leader and follower. Leader leads the dance by giving signals, and follower receives the signals and acts accordingly. By the way, this is me and my partner from a dance competition. Why salsa is important to me? Because while I'm dancing, I can express how I feel freely. And also, I can socialize after working from home. And lastly, I can get my body moving after a whole day of sitting. So let's start with finite state machine. It helps us to describe systems with cute circles, which are called states, and arrows, which are called transitions. So for example, when the light bulb is switched off, when it's not emitting light, when you switch it on, you go to the on state, and it starts to emit light. And when you switch it off, it doesn't emit light, so it's back to the off state. Let's construct the same for salsa. In salsa, follower determines the line that the dance will be made on. So with this information, there are only 3 positions that the leader can be, and we'll inspect those. The first one is basic position. Basically, leader is on the line. Let's see from examples. These are, again, from competition. I am on the line that my partner sets on, and direction doesn't matter in this finite state machine. And the next state is cross position. In cross position, you're out of the line because your partner, your follower, will cross across the line. That's why it is called like that. And the important part here is that leader is above the line. So this is a cross position. When you see it like that, it makes sense. In reverse cross position, it is similar, but you are below the line as a leader. And it is like that. So, these are the all states of salsa. There are only 3 states. And let's talk about transition between them. For example, if you're in basic position, you can move to each state, also including basic position itself. And when you do this for all 3 states, there are a total of 9 transitions that you can find. And I assure you, every dance move on the dance hall is one of these 9 transitions. And let's inspect from this video. Sorry. I am on the line here. It's basic position. I am out of line, above the line actually. It's cross position. I am back at being on the line. And now I'm below the line, which is reverse cross position. And then I am in basic position. So after constructing this finite state machine, to get better in salsa, you can do 2 things. You can count the dance moves you know for each transition and identify the bottlenecks. For example, when you're transitioning from basic to reverse cross and you only have 1 dance move there, you can learn new dance moves and you can increase the variety. It looks better. And also, don't repeat yourself. You can replace the repeated dance moves with the moves in the same transition. And for example, if you are using one specific dance move while transitioning from reverse cross to basic, you can use the other ones to add some variety again. So this sums up my transition. You can think salsa as only 3 states, and every dance move is one of those 9 transitions. The rest is the story of you and your partner. Thank you for listening.
Please.
Hi, I'm Alex. I'm pretty nervous because I haven't talked in public since my education, which was too many years ago, let's say. And I'm going to talk about an event that, to my knowledge, only happens in Spain at the moment and has happened in the past in Argentina, which is the PyCamp. What is the PyCamp? The PyCamp is basically like the experience of this conference, just way more. This year, for example, was 30 people living in like a holiday house for 4 days, sharing rooms, sharing food, sharing everything, and then working together on projects. For example, on the first day, we decide on what projects to choose. So everybody at once proposes a project. Don't ask why he's wearing that. That's not relevant. It's not a very serious event, in case you haven't noticed. And the first day, everybody proposes, then we vote, and then there is like a small schedule made, like which days are going to be each projects, and everybody chooses what they want to work in. It's not strict. It's not at all strict. Like, you can be very free. You can go and just lay in the sun 4 days. Nobody will mind. There is even a place where the tables these are the tables where people want to stay alone in their own, and those are the rules. And for example, this year, one of the projects was a laser tag, which somehow we managed to work in 2 days, actually. I don't have actually a video of the laser tag, but this is, for example, the connections, and this is the live when we were trying to play. Okay, this wasn't good. Each player was a bad programming language, let's say, or the one that we don't agree, and we were just shooting each other with laser pointers, which it had a big issue, which was it was too slow, the live training. So we got tired before before anybody died in game. Really tired. And it's pretty free. Like, the entire house is up to us. The food is done, everything is done. You just go there and do whatever you want. For example, this year, it was my first time attending, and I only coded half of one morning. Every time else, I was just talking to people, learning stuff. I did a small project in Django, which was mostly following the tutorial with some people that were completely new to it and helping them. And this is the house, for example. It was up to us. And here's the repository where I share everything that you can see, in case anyone wants to scan it. And if anyone has any questions or wants to get in contact or wants to organize something similar in their country, which we will be the organizers of the PyCamp, which I'm not one of them, but in contact with them, we'll be very happy to help. Feel free to find me and ask. That's all.
All right, thank you. My name's Kio. I work for a company called Flextricity, based right here in Edinburgh. Shout out to my boys, wherever you are. I'm on fostodon.org as Sekenre. That's how to contact me. And I have written my own time series database just to store some of the data that we deal with at Flextricity, which is an energy company. So why do you need time series data? What's special about it? I was looking at Parquet, which is a file format for storing various kinds of data frames like you would use in pandas. And I was reading Facebook's Gorilla paper about how to compress time series data, and I thought, I could do that. So let's have a look at some graphs. Every presentation needs a graph, and this is one of the graphs that we have in Flexitricity. So it's a set of samples where each sample has an exact time of when it was measured. Samples usually from some kind of analog measuring device, like a temperature, a frequency, power, flow rate. It might be a digital signal like on or off, or the state of a relay. These measurements might be coming in very rapidly from many different sources at once, and they need to be cataloged, summarized, and stored compactly, especially if you don't want to throw anything away. For a long time, Flexitricity has never thrown anything away. We're rethinking that now. Usually timestamps are sent like an ISO string, values as a floating point number, decimal strings, takes up some space. The timestamps are generally always in increasing order, and usually with a fixed interval between them, like a sample rate. Multiple samples associated with a single timestamp. Quite a lot depends on this being true for aligning the data for multiple different sensors. And the values are samples of continuously varying quantity. Sharp discontinuities are usually an error or indicate something wrong, so they happen rarely. So you can store data sequentially in different ways. You can do it column-oriented or row-based. So keeping row data together means you can get all the columns for a particular timestamp at once. And this is how most relational database systems work. The only problem is it's difficult to make it compact because there's a lot of variety, the different kinds of values. They're slow if you just want a subset of columns. But if you keep the column values together, adjacent, they're easy to compact because each value is related. You can do fast range queries for a single column. So like months worth of data for a single column is really trivial. And it's easy to summarize along the time axis. So you can do minimum, maximum, average. You can do statistical stuff over a much larger chunk of data than, without having to go through each row. They're slow if you want to do multiple columns at once. So that's a trade-off you need to be aware of. And you have to store the timestamp once for each column. This is how I compact the data. This is based on Gorilla. Storing a timestamp takes a lot of space, so just storing a number as a decimal string. The total of that is 30 bytes. So we could store it as a native binary format, number of milliseconds since the Unix time, encode that in 8 bytes as an int. The problem is most values can't be accurately represented. So if I pack that as a 32-bit float, what I get back out isn't exactly the same value, is it? But at 16 bytes, it's much better. Let's see, can we go smaller? Yes, we can. The trick is we can scale it. So the timestamp is the same as before, but this time we're scaling the value to an integer because we don't care about the 4th decimal place. We just multiply it by 1,000, we've got an integer, and then we can pack it into a 16-bit integer. So much less space. Then we can take advantage of the relatedness between the values. So we can do a difference between consecutive values and get much smaller integers that take less space to write. So we can also do double differencing, as you can see. And then we can also do run length encoding. Identical values, you can say there are 4 trues and then 1 false. Takes up much less space. We can also do variable length binary encoding. So we can prefix values and say this is a 1-byte value, this is a 2-byte value. For example, I can compress all of those numbers into just a few bytes there. So we actually use this crazy experiment in production. The total size of the archive is 61 gigabytes. The total number of data points is 58 billion. Bytes per data point, 1.09, which I think is better than Gorilla. Yes. Number of sites that we collect data from, 13. The longest time, 791 days. This is back 6 months ago when I
Kio, you've
wrote
run out
this.
of time if you're just wrapping up.
Yep, sure. It's really good to do this to learn a new thing. And
all right. Thanks very much. So my name's Amiel. I'm a software engineer at Lindis Health, and I'm going to be, I'm sorry. I think I was using a different version of these slides. That was for something else. I was editing it. Let me just do this. Oh, sorry. So embarrassing. I'm so sorry. I don't stand by that. Okay, sorry. My talk is version control is important because mistakes happen, and it's good to know what the previous version was. So version control is especially important for us, Lindis Health. We work in clinical trials. That means that we need to have really good traceability for all our data. If any data changes, we need to know who changed it and why and what it was before. So the problem, I'm lazy. I don't really want to figure out how to have version control across all the objects in my Django app. Also, I'm lazy. I didn't think of any of the problems. But thankfully, there's a solution for me if I'm lazy, which is using Django Reversion. So it's an app or a library that'll allow you to have version control just built in automatically. Any change is made, it's recorded. Awesome, great. There's still a problem though. It doesn't work out of the box for data migration. So if you change data within a migration, you won't have that version history, which for us is really, really important. So it's a real problem if we don't have that version history. The solution is you can write a quick context manager that'll handle creating the reversion objects for you within the data migration. So when I say write a context manager, I mean copy a bunch of code from Django Reversion into a context manager, because like I said, I'm kind of lazy. So here's what I did. Created this context manager, a migration revision, just set it up, getting a bunch of models ready. You can create a user if you don't have one, and then create this method here, save object, which will replace object.save inside migrations. Then here we have a bunch of stuff to make it work as a context manager and keep track of all the revisions that are happening within a migration. And here's what it looks like in practice. Within a migration, if I want to make a change that's recorded as part of reversion, I have migration revision as migration revision. I'm taking this book, I'm changing the publisher, I'm using migration revision save object instead of book.save, and then I'll have a full history of anything that happened during the migration. And that's it, very quick.
Hello, yeah, so I'm David Seddon. I love layers. I've loved layers for many years. Maybe you will soon, in a couple of minutes. So I work for Kraken Technologies. We're one of the sponsors. If you haven't heard of Kraken, we're part of Octopus Energy. And can I ask anyone what the significance of this number might be? Any guesses? Shout something out. I'll give you a clue. It's related to our code base. It's the number of modules in our code base, okay? We've got a really big code base, and it means that we've had to learn how to control complexity and to think as software architects, and that's what layers gives you. So this is a sort of picture of a kind of classic Django project. Maybe you've got a handful of apps, and they've got some interdependencies with them. And we might start with something like this, but maybe that app might need to know about that as well, and maybe that one might need to know about that, and suddenly you got this. Who can relate to this? Has anyone got? Yeah, basically everyone, because this is what our software inevitably becomes like if you don't control the relationship between your modules, and that's what layers is all about. So what can we do about it? We can impose constraints upon these relationships. So layers is an architectural pattern which just talks about, in this picture it's Django apps, but it could be anything. It could be any software component. It could be like microservices, or it could be Python modules. It could be anything. But the idea is you just have a list an ordered list of different components, and the dependencies between them flow downwards. So it's like a metaphor. So at the bottom, you've got your first app, that's like the foundation, and then the next one sits on top of that, the next one on top of that, and so on. And the ones lower down don't know directly about the ones above them. Pretty simple idea. Just to sort of try to make this a bit more concrete. So here we've got a module called blue, and that imports green. So this is all I'm talking about here with these diagrams. You know, blue has got an arrow towards green. It kind of means imports or knows about. So for Python, or particularly for a Django project, maybe this is what a layered Django project looks like. You've got a load of apps. They're all kind of siblings of each other, and the imports between them are only going to go in one direction. Now, you may ask, well, what happens, though, if the dependencies go in the other direction? What do you do about it? The answer is something called inversion of control. If you haven't come across it, it's a really powerful technique. It's not that hard. You're probably very used to it because you've worked with Django, and Django's got lots of inversion of control in it. But basically, in this case, if we didn't want blue to know about green directly, we'd sort of do this kind of plug-in mechanism where it kind of indirectly knows about it by green plugging into it. There's some links in my blog where you can search here if you want to hear a talk about it. Finally, how do we enforce it? Linting. We've got this linter called import linter. You can install it, pip install import linter, and you can define a contract that describes the layers. So here we have 3 layers. Blue is the top layer, green is the middle layer, yellow is the bottom layer. And then if you put this in your continuous integration pipeline or whatever, and then you run it, if someone introduces an import from, say, green to blue, then it will fail. And so that can allow you to like impose these constraints, which means you keep a modular and easy to work with code base despite it gaining more and more complexity. So that's what I wanted to communicate. I appreciate I've just scratched the surface, but come and talk to me more about them, or have a look at my blog if you like. And I encourage you to give layers a try, even if you're working with quite small code bases. I use it for everything. Thank you.
Thank you, David.
Okay, today I want to show you a small package I've created a couple of weeks ago. And basically it's how class-based emails will save your day, at least if you work with emails and Django. I work at a company named Ambient. It's in Cologne, and okay, I'm still there. We work with Django since 2010, so quite a while. And in my time, I've worked with about 20 Django applications, and we always had the same problems, like HTML and plain text. You have like 2 templates, it's not dry. You have global variables, which you have to declare for every email. Emails weren't unit tested, and it was kind of tedious. And so I created this package, which should hopefully help you with this. Well, this is the Django docs about emails, and that's more or less it. And it misses a couple of things like internationalization, logging. You know, you have an email template, maybe you want to have additional headers. It's all documented how to do it, but it felt a little bit tedious and not dry. And so similar to class-based views, there are class-based emails. On the right, you see an example. And it encapsulates all the low-level stuff, like from this page here. So you don't have to worry about it, how Django actually sends the emails. You don't have to have duplicate templates for the plain text and the HTML part. It's less code. It's testable. I come to this in a second. And it's super easy and fast to create new emails without having to think about all the stuff you have in your application. And the key features, it's clean. You can create a setup. You have logging, you have internationalization, attachments. You have HTML conversion to text if you want. You can customize everything like with Django views, like via inheritance, and there's more stuff. Refer to the docs. I actually wrote docs for this. So, about unit testing. If you have ever worked with the Django test mailbox object, it's kind of hard to work with this. So I built a wrapper. It's part of this package, which basically you can work with the outbox like a Django query set. So if you want to see, hey, does my test send emails? Is the email with the subject like this? You can basically do a filter, or you can make assertions. You can make an assert for both parts, for the HTML part and the plain text part, and all the stuff you know from the ORM. And in case if you're wondering why it's called Pony Express, there was a pony-based mailing service in the US, and yeah, as you know, the pony is the Django mascot, so it's an ingenious name, right? And yeah, feel free to try it out, and thanks for listening.
Thank you, Ronnie.
Thank you. So I think some of you are probably familiar with this game, Pokemon Go, where people take the smartphone and go outside looking for virtual creatures and animals. I think that if you really want to go out with your smartphone, I have a better suggestion, which is use something like iNaturalist, which is a citizen science project, where basically you will looking for real creatures, real animals, plants, mushrooms, whatever. They are important in this kind of data, this kind of biodiversity data. You have three important things: what is there, where is it, and when is it observed. You can have more things like the live stage, who observed an animal, or things like that. But really, the what, when, and where are the three main questions. So if you go to iNaturalist.org, you have a website. You can explore kind of data and previous observations by other people on a lot of different angles, like all the observations in Edinburgh, species I observed myself, details about a given species of ladybird, those kind of things. What is interesting, and the better way to use it, I think, is to use a mobile app, which exists for Android and iOS. Because if you remember those three important points, what, where, and when, it's quite easy to capture good data with a smartphone, because your phone perfectly knows where you are, it knows what time is it, and you have sensors like the camera that allows you to take picture and prove that the organism or the plant, in that case, that you observed has been really there. I'd say that the when and where questions are quite easy. The what is much more touchy and difficult, because people have opinions. Sometimes it's really difficult to distinguish species. So iNaturalist has a mechanism for that. When you add your observation, you can say what you have seen. Sometimes it will be something generic. Sometimes it will be something very detailed, because you know your topic. You will have to upload some proof, generate a picture, and then the community can refine and can discuss, and you can have those kind of exchanges. And people, after a few exchanges, generally where you have specialists chiming in, and you agree to some community identification. The benefits to do that, I think the first one, for me, I think that's really something fun. You can become curious, you explore your surroundings, you learn a lot about the species you observe, because you will want to say, oh, this is that kind of ladybird and not that kind. You will have to spend time on Wikipedia or other sources to really learn things, and the more you learn, the more you're interested in nature, the more you respect it. So it's something really, really fun. The data is really useful in the real world, because once it attains some quality, it's considered research grade by iNaturalist, and is published to a big data aggregator, which is called GBIF. And then there, it's used basically by everybody that needs biodiversity data for research. You can see here the iNaturalist data set on GBIF, because GBIF is an aggregator and has data from many sources, and there are currently 62 million observations, and it is used in 3,600 scientific publications that are referring to this data for this research. Yeah, and there is more to that, of course. Sometimes people gather together and have a big event called a BioBlitz, where you go to a place at a given time and everybody is looking with the phone in a situation like that to really have a good cartography of what happens there. There is a huge community on iNaturalist with discussion forums. People are developing and customizing cameras to take pictures of very specific things like bacteria. And of course, since it's a community of developers here, iNaturalist can be also accessed via APIs. Python packages are available, and many more things to have fun use that. Yeah, and I'm not affiliated with them. I'm just a fan, so I wanted to share. Thank you.
Thank you for the foot stomping. Is it here? Cool. Hi, my name's Colm. I'm a Python developer. I'm the author of a Python library called strict YAML. I made it because YAML is kind of nice to look at, but it can be painful to edit. And I wrote this library, strict YAML, so it's nice to look at, and it's also nice to edit. So, I'm not here to talk about that. Let's build a feature in a Django to-do app. So we start off with specification. Given that I'm logged in, when I want to add buy bread to my to-do list, and then I should see buy bread on the to-do list. Very, very simple. Don't really need docs for this, but I can't do anything more complicated without going over on the talk. So let's build the app. And with the app, we've got a Django app where we log in. This is a Django app. You log in, and then you add buy bread to the to-do list, and then it appears on the to-do list. All very simple. What's the next thing you do? Well, you only write a test. Who here has used Playwright? Cool, quite a number of you. So this is a Playwright test. So you start off by loading the web page, and then you fill in the admin password, log in, add bread, and then at the end you do a range as act assert, the normal testing pattern, and then at the end you check to see that the thing you added at the bottom is there. So that's one test you could write. Now comes the tedious part. You have to write the how-to docs. So I find the great, Daniela's Diatex's documentation framework is great. This is like how I fit all of my docs into, for any app I write, for any project I write. This one fits into the how-to guide. So we're going to have how to add an item to my to-do list. And I think I've got the docs here. This is the kind of docs we want. So when you enter text admin on username, log in, then you see his login thing, and then you enter text add bread, and then you should see add bread appearing down here. All very simple and quite common, and worked with a lot of people who've written lovely docs like that for me. This is where we get to the point where if you write this, you have the 3 stages of documentation grief. 1, anger. They're only going to go out of date anyway. 2, bargaining. Maybe I can get ChatGPT to write it. You can't. 3, acceptance. Either screw writing with docs, I'm not going to do it, or fine, I will do it, and I will get really bored. But what if you could write a specification once, and you got your specification, you got your test, and you got your docs? You'd have to write your docs not in Python. You'd have to write your tests not in Python. You'd have to write your specification not in Python. You have to write it in something else. So I propose strict YAML. So this is an example equivalent to the Python test I showed you over on. So we got a little description at the top. We got a given the story is based on logging in here, based on. And then you have a series of steps following that, like I entered the text in the to-do text, add bread, click add, and then it should appear, add bread. It should say the first one at the bottom, but it's cut off. And then you add some code for these steps, so you can execute these steps. These are the ones from this particular test. And the first one loads the website, and the second one, it enters the text. It's all very simple stuff. But this is you always need some code to execute your tests. And then the third part is you need something to take this and then to generate the docs. So this is Ginger 2. So you have this Ginger 2, which writes out the docs that I showed you earlier. When the website's loaded, show an image screenshot from the test that was generated from Playwright. Enter text using the text from the YAML doc. Click on the item referenced in the YAML doc. And this means you can rewrite your code, and you can make changes to your test. And then once you run a test, you will get docs out the other side. Right, waiting for a fake test to run. And here we've got some nice docs. I have a little video of it at the top and the changes that I've made in the test. And the screenshots you see include this change. This is what I call triality. You can do test-driven development with a spec. It means you can do, once you've written a feature, it's already documented, and it means that docs are up to date by definition. Thank you.
Yeah, until a couple of minutes ago, the first sentence in here was asked Mark to come up on the stage and lay on the back next to me. It's not in here anymore for the reason he just mentioned. So for about a year and a half now, I've started volunteering in the disaster relief unit in Germany and also doing a bit of medical and civilian protection. And as part of my involvement there, I just recently went through a 12-day medical first aid training. And that included, similar to what Toby mentioned this morning, a lot of repetition, a lot of practice to actually do things. So something that I figured might actually help some of you. I don't know who of you may have gone through a first aid course at some point, maybe doing getting a driver's license, which is something you need to do in Germany, going through a first aid course there. And yeah, so I figured I'll give you a bit of basics in general first aid. When you see a person laying somewhere or lying somewhere and you have no clue if they are still alive, well, how do you know if they are conscious? Well, you take a look at them and then you get a very good first impression. Are they pale? Are they blue? Is the face just completely sweat wet? Or is the skin wrinkly, dry? These are indications for medical professionals which they can then derive more information from. Then you address them, talk to them. Hey, are you awake? Can you talk to me? And if they don't, you start to gently grab them by the shoulders and shake them a bit, not heavily. Don't smash their head on the ground. That's not going to be helpful. But just try to wake them up. If they wake up, great. They're awake. They're conscious. Check if they're all right, but go on your merry way. If they're not, if they don't respond, there's essentially one thing you need to check now. Are they still breathing? And there's essentially three things you need to do in that regard. First of all, in order for you to breathe, your airways, so mouth and throat, need to be empty, need to be free. You do that by, well, just opening the mouth and see if there's something in there. If there's not, great. If there is, try taking it out. If it's empty, then you need to make sure that they can actually breathe and there's nothing blocking somewhere down in their throat that you can't see. And a practice or a trial for all of you, when you keep your head at a neutral position, you can breathe and you can swallow. Now, if you recline your head all the way, try swallowing. You can't. You can't really, anyway. And that's the thing you need. It's a human, or the way the body is built, to prevent you from choking on vomit or anything that may come from your stomach. So in order for the person to keep breathing, you need to recline the head all the way, which is further than you think it might be. So you recline the head, and then you listen for breaths. 2 to 3 breaths within 10 seconds. If you hear them, if you can feel them on your cheeks, great. If you can't, consider they are not breathing anymore, which means you need to perform CPR. CPR is a process of you pushing their chest such that you make the blood flow through their body. But before you start pushing somehow, yell for help, because you will need that. It's exhausting. trust me, we've done that for 20 minutes in the morning to wake up a couple of times. Then get out your phone, or get the other person or other persons who are there, have them get out the phone and call for emergency services. That's 112 in most of Europe. That's 999 in the UK, if I'm not wrong. It's 911 in the States. But honestly, in most countries, you can pretty much pick any of those 3 numbers, and it's probably just going to work. But still, like, it's probably better to remember those numbers. Also, on Android, if you push the power button on your phone several times and you enable the feature, it's just going to call the emergency services. So I'm sure Apple has a similar feature. Enable that, it can help quite a lot. So put the phone on speaker next to you if you're alone, and then the next thing is that you need to find the person's center of the chest, which is about here, and you start pushing. Stretch your arms and push. Like in many movies, you see people like pushing like this. That's not going to work. You need to push with your whole upper body because the chest is fairly strong, and you will need to push 5-6 centimeters or a third of the chest of the person's chest in order for the resuscitation to actually work. At 120 beats per minute, so twice a second, there's plenty of YouTube videos with suggestions for songs that you can sing in your head, like staying alive, staying alive. Yeah. And you don't stop, ever. If you're starting to get exhausted, switch with another person, have them come to the other side, count down from 5, 4, 3, 2, 1, and have them take over. You try to not stop for more than 10 seconds, because then you start building up the pressure in the blood vessels, all from scratch. Which is also why from the American Heart Association, you wouldn't do like mouth-to-mouth breathing anymore. That essentially means all the blood pressure drops again. And then if you're not alone, have somebody get an AED, because that can be also life-saving. Now they are alive, or they still breathe, and that's where Mark would have been my useful dummy here, where you would have put somebody in the recovery position. And there's essentially 2 positions. The old one, which people probably learned years ago, it's fine. It's slightly more stable when a person lays on the floor, but it's a bit more complex to do. The new one is, frankly, much easier for somebody who doesn't do it regularly and doesn't practice it regularly, and it also works fairly regardless of the weight of the other person. So as an explicit, like, contrast example, even a very thin, small person can flip over a person which is like 4 times their weight, just because the angle of the leg that you see in the third picture is a lever that just lets them fairly easily flip their entire body onto the side. Once you flip the person onto the side, remember what you had about breathing. Recline the neck and check for breathing once a minute. As long as they keep breathing, great. And I hope you now call 911 or the appropriate number and have EMT take over at some point, but keep checking for their breathing. If they don't, flip them back, CPR, back where we just were.